So for my experiment called pull-up power, we're going to look at the relationship between work and power through the lens of a movement that I'm sure everybody has heard of, and that's the pull-up. So we had a few inputs to the experiment. We had my body weight of 220 pounds or 99.8 kilograms. We had the weight of a backpack, which was 25 pounds or 11.3 kilograms. And then we also had a displacement from chin to bar of 22 inches or 0.559 meters. Additionally, we did 3 reps per iteration in the experiment, and those are our givens. So to calculate the work done with the backpack, we can take the formula for work of FD cos theta, where F is the applied force, D is the displacement, and theta being the angle between both the force and displacement vectors. For that, our formula basically comes down to mgh. And for the backpack iteration, we had a total weight of 111 kg. That is backpack plus body weight, times we had our total height of 3d for the 3 repetitions, or 1.68 meters, times g, yielding a total work output of 1.83 times 10 to the 3rd joules. Now for power, we can do it over here. We can use the formula we defined earlier in the semester of work divided by time. For backpack iteration, it was our 1.83 times 10 to the 3rd joules divided by 5.26 seconds, which it took to do the 3 pull-ups, for a total power of 348 watts. We can record those numbers up here. And we can go ahead and erase these numbers. For the iteration we did without the backpack. So without the backpack, we can, again, we have our work, FD cos theta, coming down to mgh for our experiment. For the non-backpack iteration, that boils down to 99.8 kilograms times the same displacement of 3d, or 1.68 meters, times g, giving us a work for this iteration of 1.64 times 10 to the 3rd joules. Similarly, we can calculate the power being the work done divided by time. For this iteration, we have our 1.64 times 10 to the 3rd joules divided by 3.85 seconds for this iteration of the 3 pull-ups without the backpack, yielding a power of 426 watts. So we can compare these numbers with the numbers from our first iteration up here, and we can see that with the backpack up here, iteration number 1, we actually did more work at 1.83 times 10 to the 3rd joules. However, we were actually more powerful without the backpack. That's because the decreased mass allowed us to do the 3 pull-ups in a reduced time. And that reduced time in the movement led to a greater power output. So I hope that's a little review of work and power for you. Thank you for watching the video, and I hope you guys have a great rest of the day.